said, oh, I have released
Questioning the election. Yeah, but like, what's the word? There's a word.
Questioning? No.
Like, a word for correct.
No, it's because.
Like, you know what I'm saying, like questioning the something.
You're questioning the outcome.
Like how right it was.
Yeah, like how, yeah.
Okay, guys, I actually made a change to the notes, so even though we have a packet, I'm gonna give you guys a new.
I can't say this word.
So these.
How many?
Yeah. So I think Brandy.
Ice.
I think Rambler. He's like, what was that?
So we're doing just this. I know, because everyone was like crowding around you, like ready for you to respond.
Oh my gosh, the phone numbers, that's like 3
Telephone numbers in the US.
Andy, you're in.
I get it now.
It's one sheet, and then. Who said this?
This is from a real phone number.
It's a real phone. Oh my gosh, why are you back?
That's why exchange numbers.
Yeah. I hate probability so much.
I'm thinking.
Yeah.
That makes sense, though.
Really?
Especially like the correctness of something. I can't think of the word.
All right, are we good, guys?
Yeah, so about what I missed yesterday is there's a video on it, correct?
Yes.
And then does it have the assignment that I missed as well? Or should I write that down?
You guys, did we do a worksheet yesterday or a book assignment? Book? Yeah, do you know how to find it at Schoology?
Sure, yeah, I think.
Otherwise,
Oh, yeah.
you go under like our class and there'll be weekly snapshots and go to week 8. Okay? All right. Why?
So they get out an hour early.
Would you be mad if I did a speech questioning the reality of the election?
That's tough.
No, I didn't. Or would I be protected by my rights?
I would ask your teacher that. I try not to get involved. What are we doing? Are you guys teaching or what?
Yeah.
Yeah, Matthew, that's make a dynamic.
Yo,
Okay.
I actually teach like. I want to see this more.
What?
Okay, are you guys good?
I just gave up.
Everybody has the notes out?
There's no way.
All right, let's get this going.
Oh, I didn't get one, Bob.
Guys, looks like we're not getting notes for today. So
Did I not give one for Nolan?
No, no one doesn't get one yet.
Is there one?
So bad.
I'm not the smartest.
All right, so, what do you need?
Yes.
Yeah. I'll grab one for you, Matthew.
You know what? I don't
I don't know
think
how
you
to do
need,
homework.
well,
Are we just doing the same thing as these last two?
just one extra step. Okay, so
Mom,
we
you can
are
just use your
going
phone.
to learn a similar type of problem. What we have been doing, they're called rational equations, which means you have fractions, okay? You have fractions with x. That's basically what a rational equation is. Today, what we're doing is rational inequalities. So the only difference between the other days and today is it's going to have a less than or greater than or less than or equal to sign. Okay. The difference, the thing is, what you're going to do is just like yesterday and the day before, where we come up with the LCM. So can you guys think of the LCM between 3 and 9? 9, right? Right? And then wouldn't you just
Garbage.
and then wouldn't you just need an X? Do you guys get that?
Yeah,
Now, what can X not equal?
0.
0. Everybody understand that? Okay. So down here on your number line, what you're gonna do is at 0, you're just gonna draw a 0 there, and you're gonna put an open circle. Okay?
Why does this gotta be so
And
hard?
that is because it's called a critical value. Whatever your x can't equal here is a critical value down here. All right, now what we do is we solve this just like we've solved them all week. We put, well, you can just think of this, you don't really have to rewrite it, but you're gonna solve this just like we did all week and think of this as an equal sign, okay? So how we did that, if you guys remember, is we took our LCM times every term, right? So we go plus 9x times 7 over x equals 9x times 5 nines. Quiet, you guys. Now, if I look at this, I can look at what can I get rid of? And do you guys get, if there's an x on the bottom and the x on the top, can't we get rid of these x's? And then how many times does 3 go into 9? So I'm going to make this a 3 and get rid of that. And 3 times 4 is 12, right? Okay. Now, can't I get rid of these x's here? And 9 times 7 is 63. And then here, I can get rid of the 9. And 5 times x is 5x. And now I just go ahead and solve that. 12 plus 63 is 75. And then I'm going to divide by 5. And x is 15. Okay? Now, whatever you get for x becomes what's called a critical value down here. And you're going to put an open circle there if your sign is less than or greater than. And the way that I did this, as well as I'm working on your practice test and test right now, I did all of them, at least in the homework, I hope it's like this too. If it ever says less than and equal to or greater than or equal to, don't do the equal part. The examples I have aren't that way. So just always do less than or greater than. Do you understand that? Okay. So what we're going to do is come down here. And what you have to do is you have to try a point in all 3 of these regions to figure out where your values are that are going to give you this. Okay. So here's the deal. You're going to choose any negative number that's less than 0. What I would do is try -1. Okay? Here, you can try any number between 0 and 15. I'm going to try 1. And here, we're going to try any number bigger than 15. I'm going to try 20. But you could try any. Okay? Now, so what that means is you're going to go back up to that original equation here. Okay? And you're going to put those numbers in there. Now, do you guys get it? If I put a -1 in here, because that's what we're trying first, do you guys get it would be -4/3? Right? And do you get, if I put a -1 here, 7 divided by -1 is -7, right? And so we're going to check, is -4/3 -7 less than 5 nines? Now, you can put that into your calculator. You can go parenthesis -4/3 parenthesis -7. Can't you tell it's going to be negative? Yeah. And if it's going to be negative, isn't it going to be less than a positive number? Okay, so this is going to be yes. So what that means is our graph is shaded here. Okay, then we're going to try the one in the middle. I can tell you most of the time, you guys, when the one on the left is shaded, the one on the right will be shaded, and this one will not. But you do have to check, because every once in a while, maybe both of these will be shaded and this one won't. So we do have to try. So what you would do then is put 1 in here. And you guys get here, you get 4/3 when you put 1 in here. So you would check, is 4/3 plus 7 divided by 1 is 7? Is that less than 5/9? Can you tell just by looking at that it's not going to be less than? So in the middle, that means this is not shaded. And then we could try 20, okay? So if I put 20 in here, do you guys get that that would be 4/60? Okay. If I put 20 in here, do you get that would be 7/20? And is that less than 5/9? So what I would do is go on my calculator and I'd go parentheses 4 divided by 60 parentheses plus parentheses 7 divided by 20 parentheses. And did anyone do that? What'd you get? Okay. Oh, that's gonna be really close. And 5/9, isn't that 0.5? Oh, this one is 0.41?
So,
5/9, isn't that 0.55? Okay. And then what did you get for this? 0.41. Okay, that makes more sense. So, do you guys get, isn't this a true statement?
Yeah.
Okay, so that means this is going to be shaded here, okay? So then what we have to do is write, okay, where is our answers, or where are our answers? And our answers, our variable is x. So our answer is x is less than 0. Do you get that's what this is? Or, whenever you have 2, you always connect it with or x is greater than 15. You understand that? So when you have an answer today, 99% of the time, you're gonna shade either on the left and right or in the middle. And I think all of your examples are gonna be like that, okay? But this is your actual answer. All right, so now let's go to this one. Again, what does 3, 5, and 3 go into? 15, and wouldn't it be 15n would be our LCM? Mm-hmm. What can n not equal? 15 times what gives us 0? 0, right? So, because you can't have a 0 on the bottom. If it's like just a number and a variable, like 7x, so it's 8y, they're always 0. So you're kind of thinking like 15 times what would give me 0, and it's 0. Okay? Now, once you've figured that out, you can kind of just think of this problem as an equal sign, and you're going to multiply every term by the LCM. So I just took all 3 terms and multiplied by the LCM. Now, do you guys get here that my n's are going to cross out? And 3 goes into 15 how many times? 5. So do you get what I have left here is 5 times 2, which is 10? Everybody understand that? Mm-hmm. Okay. Now, don't my n's cross out here? And 5 goes into 15 how many times? 3. And so what I have left here is just 3 times 4, which is 12. Okay? Oh, and I can think of this as an equal. Okay? And this I can think of as an equal. Okay? Now, 3 goes into 15 how many times? 5. So what would I get if I have 5 times 2 times 10? 10n. Then this becomes a lot easier to solve. 10 plus 12 is 22 equals 10n. Divide by 10, and n would equal 2.2. Now, your critical values, I should have wrote this down before, are always what your n can't be. So you're going to have one at 0, and then you're gonna have one at 2.2. And you wanna try a point that's in this region. I always try -1. And then 0 is, I think in your situation, the problems you're gonna have, 0 is always gonna be a critical value. So then I always try 1, and 1 is between 0 and 2.2. And then you would just try any number over here. I typically would not do 3, I would do 5 or 10. So let's do 5, okay? But you can pick any one. Now we're gonna go back up, and if I put a -1 in here, I would get -2/3. If I put a -1 in here, I'd get -4/5. And then that's 2/3. Do you guys get, when you have a negative minus, 2 minuses here, aren't I gonna get a negative answer? And is a negative answer gonna be less than 2/3? Yes, okay? So that means I'm shading here, okay? When I try 1, that's gonna give me a positive 2/3, okay? When I put 1 in here, that gives me a positive 4/5, and see if that's less than 2/3, okay? Yeah.
I'm also wondering, would you have to show you like that if it's like, if there's already 2/3 and it's just like 4/5? Do you have to show scales in your multiplication? Because it's obvious that that would be bigger.
Like, are you asking, do you have to show this?
I'm saying for like the next one, to the positive one.
No,
To show that scale.
you wouldn't, good luck, guys.
Look,
You wouldn't,
like,
I mean, I guess, no, if you tell me what you tried and you just punched it in, that's okay, okay? Now here, this one's kind of common sense, right? If you added something to 2/3, is it gonna be less than 2/3? No, but do you guys get, if it wasn't that way, do you know you could just type in parentheses 2 divided by 3 parentheses plus parentheses 4 divided by 5 parentheses, hit enter, and you would get a number, okay? And then 2/3 is 0.67, and you should find that this is bigger than this. Everybody understand that? So this one's gonna be a no. Then if I go and try 5 in there, 3 times 5 is 15. So you would check, is 2/15 plus, if I put 5 in here, that's 4/25. And is that less than 2/3? Okay, so again, you can go parenthesis, does somebody want to do this? Parenthesis 2 divided by 15 parenthesis plus parenthesis 4 divided by 25 parenthesis. And did anyone get an answer there? Jacob, what was it? 0.29. And then 2/3 is 0.67, and isn't that true? So that means down here, this is a yes. So you would be shading this way also. So again, this is one of those or ones where you would say our variable is what? N. You would say N is less than 0 or N is greater than 2.2. Okay.
I think we got it.
The only thing you guys, this last one,
Is that gonna be
Okay.
a and one instead of or?
you're gonna have, let me just look at my notes real quick. It is the one in the middle, but let me just show you how you write it. So when you guys solve this one, you should get y equals 7. And you guys get this would be 10y, and that y can't be 0. Do you get that? So you'd have 1 at 0, and when you solve this, you're gonna get 7. So you're gonna have 1 at 7. Now, what happens when you try these three, this one's gonna be a no, this one's gonna be a yes, and this one's gonna be a no. So how you write your answer when it's in the middle like that is your variable is y, you put y in the middle, your signs would go the same way that this goes. Or no, actually, no. Your signs, regardless of the way that goes, I'm lying there, your signs are always less than. They're always less than. And then this number goes here, this number goes here. Does that make sense? Great.
Against the small end of the no. So like it has to be,
The signs, are you saying could you put these together?
Yeah.
The only way you put it together is if the signs are both the same. And if you're shading in between, because here I'd have, I think what you're saying is this.
Yeah.
Okay, is that right? But is 2.2 less than 0?
No.
So that does matter. So the only time we put them together is when it's shaded in between,
alright then.
okay?
Alright.
All right,
Two questions?
So-
Three questions?
your assignment, you have 6 problems. That's not bad, right?
That's not bad.
That's really small.
Am I right? That's small.
Don't say.
Did you think it was hard today?
Did he have such a good day when he gone, that you decided to throw in a?
Well, and I can't figure out the whole one.
No. From yesterday?
Yeah, or the day before. I got every answer I get is different than the answer. Every single one.
It's easy to make a mistake.
It's because of that.
I got you, Carol, I know, I could keep.
I have to turn in my assignment late.